Could you speak more loudly, please?
So I would be curious about the environment that would make this balance happen most optimally, because it's important to be able to be creative, but like there's creativity and then there's doing that in a structured work environment. So if that's really like say the mission or the goal of an academic institution or maybe any endeavor that you're interested in, it would be important to think about what pieces would actually make that possible.
So the comment was about what are the environmental conditions that are going to facilitate creativity? And can we find it for academics? You know, some of the Silicon Valley operations are famous for having hula hoops and punching bags and things to bounce on, just as a way to encourage people to be creative in their work. And I think in an academic setting, it's more difficult. And my academic setting is a little different than yours, and so I think we have to kind of find our own way within the limits of the institution we're working in, sort of doing what we need to survive, but being willing to break a few rules in order to protect that process in ourselves that is where the new ideas come from. And that's why I'm always doing my online training at the very last possible.
Yeah. I thought this was really useful, so thank you for the presentation. My contribution would be, I think, and I say this to my students, and it kind of builds on your comment about the 3 years of structure and then being creative. It's almost a process of building your toolbox, and then you reach in and grab what you need to address different problems. And being really mindful in all aspects of your life, your hobbies, your interests, being passionate, and learning all you can about your whole life, your whole environment, helps to build that toolbox and gives you tools to draw upon in your job.
So it's not just a matter of work, it's a matter of a lifetime. Yeah.
So thanks for the talk. I think it's good to open up this kind of space for this kind of discussion. And there's two things that are sort of related but a little tangential, both about persistence, the idea of persistence. One is I asked Tyler Vanderweel, how can you produce so much? And it was before yesterday. And
Still writing a paper today. So.
But generally he said I could write a paper a week. And the way he did it was that he built up an intellectual or mental endurance. So he had a day a week, no meetings, in a protected place, and it took him a while to be able to spend 8, 10, 12 hours uninterrupted. But we all have the feeling that when we start working on something, it's only after maybe 30, 45 minutes that you even have your desk arranged. Right? It's the second hour that you start to cook, right? Usually by then you're like hungry. But if you can get the idea in and continue, in that third hour, things start to really hum. By the 8th hour, you're doing things that are almost inhuman. Because you remember that when you change a word on page 6, that you have that same inappropriate phrase on page 9, and you know it's on the third line. And so persistence in the micro setting, sense of building that ability, then you have to, like you were saying, you have to not be busy with other things. You have to be able to carve out that time. The other thing was with colleagues, persistence there. Because in addition to trust, I probably underestimated the words of trust, but I saw early on that I would find a colleague who might have potential but it would only be after 2 years of semi-intense work together that we had built a language where they would know what I was thinking before I could really fully frame it. And I had the same with them. And I've had a few of those colleagues and over time, but it always takes so long to develop that I fear a lot of people abandon the relationship before they get to the point where it really starts to pay off. And the interesting thing is you leave that person, you go into the world, and but if you're at a conference with that person, it's like riding a bicycle. You know that person's brain in a way that immediately gets you back working with them. And that I found, and it's also one of the most enjoyable things.
Right, that's a great comment, Stephen. I hadn't quite put it together that way, but you do develop a language and a sort of intuitive understanding of certain things with colleagues who you've worked with over a long time. And that is so valuable. It's so great to be able to pick up a conversation in the middle that if you were approaching somebody fresh, you would take a lot of background to get to wherever you are with these thoughts. So that's, that would be an argument for staying in one place for a while, but that's not a luxury that we always have. I have had it, fortunately for me, but I recognize it's not easy to control. Yeah.
UNC has a new vice chancellor for innovation. Her name is Judith Cohn. And principally what she's trying to do is foster spinoffs, mainly from technical departments like chemistry and computer science. And I went to a speech she gave about 2 months ago, and without prompting from the audience, she said something that really shocked me. She said, the software houses in Silicon Valley up to Seattle are really tragic. They have phenomenally talented people being paid at high salaries to work on tiny details. And I started thinking about that, and that's what's happened to software. We can spend hours putting in a new gesture on the smartphone to turn the screen blue because it's cool. But Judith Cohn was right. It's tragic. The environment set up at the highest level, at the university level, at the company level, has to be good. And it is not in those cases.
Yeah, I mean, you touched on something that I worry about, which is that the word innovation has been co-opted by the capitalists. It's something that, by their definition, needs to be able to make money. And I would like to think that in science, we innovate in order to come closer to whatever truth is. Yeah.
I've always heard that back in the 50s that one of the most exciting places to work was AT&T.
The Bell Labs. Yeah.
The Bell Labs, because it was supposed to be so exciting. They had no necessarily goals.
Right.
They were given total freedom. They could think about what they wanted to, and I guess it was supposed to be a very exciting time.
Yeah.
Very creative, and I'm wondering, and it had nothing to do with money. It had nothing to do with if they were supposed to be making the company money or anything like that.
Yeah.
And I'm wondering, I would love to be able to have gone back and studied that and think, how do you foster that kind of environment? In a lot of ways, I think, at least when academics can do that, by making it a fun thing to think. Reward thinking.
Yeah, I can make myself miserable by imagining what that might have been like over at Bell Labs in
Yeah, it's
1950s.
very exciting.
Perfect environment for creative thinking. But in fact, we all live in the real world, and what I'm hoping, here's my agenda today. Here's why I'm here. I hope we talk about this. I hope we think about what is it that makes an atmosphere, a structure that that lets us better tap our own creativity. Because I think it leads to better science. And so Steve talks about making a space for this. That's what I'm trying to do. And I don't have the answers, but I really would like us to have this more as uppermost in our brain as something that's worth talking about. Because the fact is, we live almost entirely, our entire scientific lives, way over on the logical and analytic side, right? This is the culture we live in. This is how we present what we do. This is how we give talks. This is how we write our papers. Nobody ever writes a paper saying, I was really stumped on this, and then on Thursday morning in the shower, I had this great idea. You know, what they do is they say, A leads to B, leads to C, leads to D. And after you have the great idea, then you can kind of figure out a logical way to get there. But we don't talk about how these things actually happen in many cases. And the more we can, you know, I'm not trying to make us all into mystics. I could if I wanted to, right? But I think having some better balance in our lives between the clear demands for rigor and precision and accuracy and analytic processes, to have some balance with, you know, where do good ideas come from? I think that's going to help us. Yeah.
I can't remember what the name of the group is, but Mark Zuckerberg and his wife have set up this group of this funding source that they've pulled together a bunch of people, and they're all stationed in one area in California. Are you familiar with this?
No. Can you hear her? I'm going to trouble repeating it.
So Mark Zuckerberg and his wife, along with a few other people, have put together a fund for innovation in science, and they have an institution that they've put together in California that has engineers and all sorts of other people there at their disposal, and they get a grant for 5 years, and it's supposed to be some, you know, far out challenge, and it's not renewable. And the trick there is, I think that we're in this environment of, if I get NIH funding and I fail at what I'm doing, I'm not going to get my next grant. And so we're always building on that little extra bit to get us to the next step versus thinking outside the box and taking that challenge.
Right.
And so I think at a university level, if there's some ability to do that on a small scale, you know, certainly we can't fund everybody in this room full time to do that sort of thing, but putting the resources in place to have these innovative ideas that could be completely crazy, but that you're not afraid to try, I think would change things.
Yeah. It's a great idea. You should talk with your department chairman about
Talk to Chancellor Folt about that.
So I think the MacArthur Awards, in a way, are an attempt to do that same thing. You know, we think about them as the genius awards that, you know, pop up every year, but it's not so important who gets the awards as what the award is. It's cash. It's $500,000 to do whatever they want to do. So they're finding people who are going to be good investments, hopefully.
Thanks, Al, that was great. And I was reconsidering whether I should ask you my question. I was going to ask you how you came to the conclusion that we have so much logical left brain in our field and precious little right brain. And I was wondering if you had actually read the discussion sections of that paper you used to edit. I see awful lot of chaos there. And then I was going to ask you why a chemistry journal should care, or the readers care, where Kekulé came up with his idea. The important thing is his idea. But I realized I was conflicted. I'm right in the middle of teaching the deductive logic part of the course. And just yesterday we spent a half hour trying to figure out whether contrariety is transitive, intransitive, or non-transitive. So I had a conflict of interest. So instead, I'm going to ask you about the techniques you left us with. The putting yourself in a setting where your right brain can do its thing. And leaving the problem alone, taking a walk in the woods, more hot showers, smoking more weed.
Often when people do that and come up with ideas that then hold up, I can say most of the time when I have eureka moments,
That doesn't hold up, that's all right.
what we came up with looks very left-brained. So were you giving us suggestions for letting the part of our brain that works when we're not actually conscious of it do its left-brain thing? Or were you actually saying that we shouldn't be teaching people like the structured logic and methods and encourage their creativity and spontaneity instead of those things? Okay, so I let my conflict.
So, right, I mean, science is logic and rigor. I mean, that's, if we ever leave that, we're going to be lost. But it's not only that, and I think that's what I'm trying to convey, and I love your idea about the eureka moments that don't pan out. That's, how many? 5% of them pan out, just barely statistically significant. But I think that the way I think about this, and this may be, this is just my own worldview, that when our right brain has an insight that turns out to be true, I guess this is like the Indian mathematician's theorems. He didn't understand why they were true, but he came on them completely intuitively, and they were beautiful to him. And the reason they were beautiful is because they were true. And the reason he couldn't tell you how he got there, but once he was there, then somebody could figure out all the steps that it took to get there. And but I think going at it the other way, to get there just by going through these steps, we're never going to come up with many of those theorems. So intuition gives us a leap into an area of our understanding of reality it's not the same as our logic, but will be supported by logic if it's true. Does that make sense?
Thank you. That's what I was thinking and hoping.
If you'll excuse me, I have to turn this around because the last time I recorded a lecture and I said something and I wasn't on the camera, my wife was very upset. Oh. I can't take that chance again. So first of all, I don't know if you've read any of the things that Roberta Ness has written on it. Okay, because she's been in this area of innovation for a while now.
Right.
The second thing is, I was at the American College of Epidemiology meeting in New Orleans last week, and I gave a talk where I tried to present, not nearly as eloquently as you do, but I tried to present some of the ideas that you touched on also. So I'm just trying to say that you're not the only one who is wrestling with these things, and I'll certainly happily share what I've written. But I have found, you invited me to talk about TM, transcendental meditation. There is research on transcendental meditation and creativity. And early on in my practice, I found that I got very good ideas for lectures. So I was teaching introductory epidemiology, and a lot of the ideas I would get that I would use to illustrate things in epidemiology came to me either in TM or shortly after my practice and so on. And that's not, other people have said that they found that too. But not to say that other meditations don't do that too. It's just TM is the one I've been experienced with. And some of the theory behind transcendental meditation, which at one time was called the science of creative intelligence, also relates to these ideas of you've got the cosmos and the formation of the cosmos, and then the way that has evolved into the planets, and then the molecules and the various life forms and so on, that all of this has similar principles underlying it, so that you can find patterns in the brain that you can find out in various aspects of biology, and you can also find them in physics. And they have written on this in their publications and whatnot, and I've got a book in my office about enlightenment where they present some of this. I'll be happy to share it with you. And the last thing is that it may seem, it does take a lot of time to practice TM, 20 minutes morning and afternoon every day. Yet Tom Frieden, the director of the Centers for Disease Control, mentioned in an interview he gave in the last year, he said, this is the first time I've told people this, that he's been meditating for 40 years, 20 minutes in the morning, 20 minutes in the afternoon. So people you wouldn't realize, Kamara Jones actually said last Friday that she actually learned TM when she was in high school and has practiced it on and off over the years. The Surgeon General, Vivek Murthy, the former Surgeon General, talked about a program in San Francisco where the children in the public schools, in several schools, have been practicing TM morning and afternoon as part of what they call the Quiet Time program, with a terrific impact on this school experience. So, yeah, it's hard to get the time. I don't deny that. But you're suggesting a number of ways, and TM is one that I think people should give some thought to.
Thanks, Vic. And I think I'll close with a comment on that. I didn't mean to imply at all that what I was suggesting was a full catalog of the possibilities. And there are lots of examples, I'm sure some that you have in this room that we haven't talked about. But my focus is on research and science. And I think having a conversation that takes into account this intuitive side is going to enrich our research in a way that I think would be useful. So if anything I brought helps you to do that, great. If things you get from other quarters that you're now more aware of, that's great too. But I think it's a road worth walking down. Thanks very much.